The USS Gerald R Ford, which is one of the world's most expensive warships, is facing persistent sewage system failures.
She is 100,000 tons of sovereign American steel. She is the most expensive warship ever built, the most digitally lethal supercarrier ever launched, and the most fiercely contested ledger entry in modern naval procurement. And inside her hull, deep in the steel, burns a fire 4 times hotter than the surface of the sun. Welcome back to the channel. This deep dive draws from public NAVSEA program statements, Government Accountability Office reports, Congressional Budget Office analysis, the Director of Operational Test and Evaluation, and verified interviews with the men and women who built her, who sail her, and who have stood watch on her bridge through her hardest years. By the end of this video, you will know what makes the Ford different from a Nimitz at the level of physics. You will understand why she costs $13 billion, what that money actually bought, and where the program bled, because she did bleed. You will also understand why a single trash bag dropped into a chute deep in this ship gets vaporized at 25,000 degrees, and why that detail tells you everything about how the United States Navy thinks about persistence on station. Chapter 1. The hull that broke the mold. To stand on the hangar deck of the Gerald R. Ford is to step inside a ship that does not smell like a Nimitz. The 30-year-old smell, hydraulic fluid, aged steel, leaking steam, is gone. In its place, ozone, cooled silicon, fresh aviation fuel. She feels like a low-orbit space station that happens to float. The Nimitz hull had reached its physical ceiling. More electrical generation meant more weight. More weight meant lost combat stability. The Navy threw the math out and started over. She displaces approximately 100,000 long tons and stretches 1,106 feet. Her crew is reduced by 600 to 900 sailors compared to her predecessors. The island superstructure was shrunk, faced with radar-absorbent flat panels, and shoved 140 feet further aft. 4 aircraft elevators became 3. The geometry was rebuilt to maximize one number, sortie rate. From a Nimitz baseline of 120 per day, the Ford targets 160 sustained, with surge capacity to 270 in a 24-hour wartime cycle. Chapter 2. The Trapped Stars. She is animated by twin Bechtel A1B pressurized water reactors, fueled by 93.5% highly enriched uranium sealed inside their containment vessels at Newport News. The legacy A4W reactors of the Nimitz-class were bound by the limits of pressurized steam. The A1B plants are smaller, require far less maintenance, and eliminate miles of steam piping. The twin reactors deliver 350,000 shaft horsepower to 4 bronze propellers, driving 100,000 tons at speeds in excess of 30 knots. But the headline number is the electricity. The A1B generates 600 megawatts, roughly 3 times the A4W on a Nimitz. That number is the justification for the entire ship, an energy surplus meant to power the directed energy weapons, electromagnetic railguns, and unmanned systems that will populate her decks in 2060. Once that uranium is sealed, the fires will burn until the hull is retired. 50 years. No midlife refueling. Chapter 3. The Slingshot. For 60 years, naval aviation was defined by the hiss, the fog, and the bone-jarring kick of the steam catapult. The Ford strips that out. She replaces pneumatics and steam with raw, harnessed electromagnetism, the Electromagnetic Aircraft Launch System, EMALS. An EMALS launch starts with a low-frequency thrum of energy storage flywheels spinning up deep in the ship. When the shooter fires, 100,000 amps dump into the linear induction motor array embedded beneath the deck. To the aviator in an F/A-18E Super Hornet, the difference is profound. Steam catapults deliver maximum force at the very beginning of the stroke. They jolt the airframe and the spine. EMALS provides a digitally controlled rolling magnetic field, tuned to the weight of the aircraft. That extends the life of the fighter fleet and allows the carrier to launch light unmanned systems a steam cat would tear apart. EMALS did not work perfectly out of the box. The Navy and General Atomics fought through years of reliability failures. By the Ford's 2023 to 2024 deployment, the system had matured. Chapter 4. The Snare. Catching a 44,000-pound jet at 150 miles per hour requires precise violence. The legacy Mk7 hydraulic arresting gear did it with brute force. The advanced arresting gear replaces that with software, electric induction motors, and energy-absorbing water turbines called water twisters. When a tailhook catches the cross-deck pendant, the AAG reads the strain in milliseconds. The water twister adjusts resistance dynamically, calibrated to the aircraft. It catches both heavy strike fighters and light surveillance drones with software precision. The AAG suffered some of the most severe developmental friction of any system on the ship. In 2012, engineers discovered that three-dimensional flow forces inside the water twister had been vastly underestimated. The internal plates tore themselves apart under pressure. That failure cost 4.5 years of testing time. Honest engineering. It bled to get there. Chapter 5. The Digital Arteries. A flight deck that launches jets 25% faster is operationally useless if the ship cannot move bombs from the magazine to the deck fast enough to arm them. The Nimitz-class moved ordnance with hydraulic winches and steel pulleys. Roughly 100 feet per minute, a 4.8-ton payload. The Ford has 11 automated weapons elevators. They run on linear synchronous motors. Same magnetic propulsion as EMALS. No cables. 150 feet per minute. 11-ton payload. The AWE program was not smooth. Software integration issues and the tight tolerances of the watertight blast doors caused massive certification delays. For years, the ship sailed with only a fraction of her elevators functioning. On December 22, 2021, the 11th and final elevator was certified. That was the day the Ford finally became the Ford. Chapter 6. The Omniscient Eye. She is crowned by the dual-band radar system. 2 active electronically scanned arrays, the ANSPY-3 X-band for low-altitude tracking and the ANSPY-4 S-band volume search radar for long-range surveillance. 3 flat octagonal panels are fitted to the island. No moving parts. They electronically steer beams for a 360-degree dome of situational awareness. The DBR replaced 6 legacy radar systems. A Nimitz suite required 20 to 25 technicians. The Ford requires 4 fire controlmen. On the bridge above, no brass engine telegraphs, no analog helms. The Ford bridge is a glass cockpit, touchscreens, integrated navigation. She feels like the next century. Chapter 7. The 25,000-degree heart. This is the one everyone asks about. Deep within the steel bowels of the carrier sits a system designed and manufactured by PyroGenesis Canada Incorporated, the Plasma Arc Waste Destruction System, PAWDS. A note on the number first. The published specification is 25,000 degrees Celsius, not Fahrenheit. 25,000 Celsius is roughly 45,000 Fahrenheit. By physics, 4 times hotter than the surface of the sun. Why does the Ford carry a small star in her belly? The MARPOL Annex 5 international regulation banned the dumping of plastics into the ocean decades ago. Nimitz-class ships compacted plastic into heavy disks and hoarded them in volume that should have been spare parts and ordnance. Those stockpiles were a fire hazard. The Ford broke the tether with plasma physics. A trash bag drops into the pod's feed chute. A heavy mechanical shredder takes it. A high-speed mill grinds the refuse into a fine lint-like powder. The powder is pneumatically blown into the patented plasma-fired eductor. Inside a sealed chamber, the plasma torch howls, a contained high-frequency electric scream. The pulverized waste hits the 25,000-degree arc and vaporizes instantly. Not burns, vaporizes. Hydrocarbon chains do not combust. They dissociate. Electrons strip from atoms. Plastic, paper, food waste. They cease to exist as molecules. A second layer protects the ship from the chemistry. The greatest risk in plasma arc processing is that toxic dioxins and furans can reform as the synthetic gas cools. Ford's system prevents that with an immediate, violent water quench. The superheated gas hits a wall of cooling water in milliseconds. The chemical state is frozen before toxic molecules can reassemble. What exhausts the ship has 0 heat signature and 0 visible plume. 200 kilograms of waste per hour. 4.8 metric tons per day. Volume reduction over 90%. The waste of a small city, eaten by a star. Chapter 8. The Ledger. The lead ship of the class finalized her acquisition cost at roughly $13.3 billion. That figure does not include the $4.7 billion in initial research and development. The Government Accountability Office and the Congressional Budget Office have not been quiet about it. 27% cost growth over the initial estimates. Cascading schedule delays caused by the Navy's decision to integrate 4 unproven major systems concurrently, EMALS, AAG, AWE, DBR, on the lead ship rather than prototyping ashore first. That criticism is correct. Defenders frame it differently. The Ford is a first-in-class prototype that doubles as an operational warship. The R&D costs are amortized over the 10-ship class. CVN-79, the John F. Kennedy, CVN-80, the Enterprise, CVN-81, the Doris Miller. Lucas Hicks, vice president for the CVN-79 program at Newport News Shipbuilding, has stated that improvements made over CVN-78 will allow CVN-79 to launch 3 months earlier than planned. That is what amortization looks like. There is also the manpower math. By reducing the crew by nearly 600 sailors over a 50-year service life, the Navy estimates billions in personnel savings. The Ford was expensive. The Ford was late. And the Ford works. She was not born smoothly. She was fought over in congressional committees, scrutinized by the Government Accountability Office, and questioned by analysts. The hull does not care about the paperwork. The hull is a testament. They wrenched the titanium fittings until their knuckles bled. They welded the steel superlifts in the freezing Virginia rain. They wired the millions of feet of fiber optic nerves. They certified the 11th elevator on a December morning in 2021. They pushed EMALS through reliability hell. They redesigned the water twister twice. They stood every watch from keel laying to maiden deployment. She eats her own waste at 25,000 degrees. She catches multi-ton fighter jets with digital water turbines. She slingshots American air power into the sky on waves of pure electromagnetism. This is the American spirit rendered in 100,000 tons of gray steel. She is the USS Gerald R. Ford, and she owns the ocean. Before you go, if this is the kind of honest hangar bay deep dive on American naval engineering you want more of, hit subscribe. Join the channel community to support deeper deep dives on the next ships in the class. The Kennedy, the Enterprise, the Doris Miller. She is the Gerald R. Ford. We have the watch.